All right. Well, welcome back to the second session of the day, and thank you all for joining. This is Keith Thomas. He's the CISO for AT&T, and Keith will be speaking on how to actually protect software supply chains from attacks. Keith, thank you for your time. Please take to the virtual stage.
Thank you all for joining. Again, my name is Keith Thomas. Today, I'm going to talk about how to actually protect yourself from software supply chain attacks. So we'll cover today what a supply chain attack is, how hackers infiltrate your organization's development environment using open source software, and then what organizations can do to protect yourself. A software supply chain attack is when your development program's been compromised. Hackers have somehow figured out how to get malicious code inserted into your organization's software programming pipeline, and it gets inserted in before it's published or before it's compiled. And then once it is, it's embedded into your application where consumers or the business uses that application. There's been a significant increase in software supply chain attacks over the past few years. And as a result, over 60% of organizations have been impacted by some form or the other with software supply chain attacks. Think about your SolarWinds or the Log4j that happened earlier this year. That's where a lot of the organizations have been impacted. So most organizations today use open source software in some form to be competitive within their industry and also to support the innovation within the developers that are working on programs for your organization. And as a result of the software supply chain attacks, our CIOs, our executives, they've begun to recognize how vulnerable their software is to open source supply chain attacks. It's also become visible above the CIOs with our CEOs and our board of directors. So they're being instructed to improve their security for software development. And so it's no surprise that budgets are increasing for software development security. I'm going to show you how a software supply chain attack can happen in a very simplified way. But really what the idea here is hackers try to trick developers to use their version of malicious code. And there's a few ways that they do that. So it could be through dependency confusion, where the hacker has created a project that looks very similar or just like the original author's project. There could be typo squatting, where the hacker creates a project just like the author's, but renames it, but it's very similar. So the developer inadvertently picks the wrong project. And then there can be malicious source code injection, where the hacker actively tricks the author to include their malicious code. Typically, it's included as a feature. So once the hacker has figured out how they're going to position their malicious code on the open software repository, then the developer downloads that code to their machine, compiles it within the application that they've been writing for the organization. And then once it's compiled, it gets distributed out to the application servers. And from there, the end users or the software that's being distributed out is now compromised and infected. So whoever uses it is now participating with that malicious code. There's a few techniques that we've seen over the years. And so I'm going to describe 3 of them. First is the SolarWinds one. And what happened here was for hijacking updates, the software, the malicious code was inserted into a software update. And then when that software update was published out to the SolarWinds applications outside for the customers of SolarWinds, they were then compromised and the malicious code was in their environment. So that's how a hijacking update would occur. Log4j, which is a logging dependency or library for Java. In this case, the open source code was compromised, but no one really noticed the malicious software in it until it was too late and Log4j was already distributed globally. And then finally, this one was hackers had stolen the certificates that are assigned by Microsoft for Windows to NVIDIA. So hackers stole the certificates, then used those certificates to build their application. And then the application was, when the application is attempted to be installed on Windows, Windows thinks that the software comes from NVIDIA based on the code signing that was provided, based on the code signing from the certificates that were stolen by the hackers. There are a few different security tool types that we can use to protect our software development environment from those types of attacks. There's the static application security testing. So this is, we actually scan the source code of that the developer is writing. There's software composition analysis. You want to know what open source and third-party libraries or dependencies are in the source code, and these tools can help identify that. They'll find those libraries, and they'll be able to present them and tell you where those libraries and dependencies came from. Dynamic application security testing. Think of this as like our traditional pen testing. We're going to test the application in a live environment and see if there are any weaknesses and vulnerabilities during runtime. Runtime application self-protection. This is self-protection tools and features within the operating system that the developers leverage in their code to protect their application. So don't avoid the security capabilities within the operating system. Embrace them and use them in your software development program so that you have better security. Web application firewalls. These sit in front of a web server and protect it from different types of attack. A really good example is a SQL injection attack. So a WAF will limit the amount of connections or the characters or the character strings from being sent through, so it can actively block that type of traffic. And that's what's used to prevent a SQL injection attack from occurring. Cloud security posture management is when it's monitoring for changes in the production environment. So if you've got an application that has changed slightly without your configuration management or change control process being involved, then it would alert your organization that something's happened and that someone needs to come and take a look. It might be malicious code, it might be an accidental change, but it gives you an alert so that you can go and identify what the issue might be. Those are the application security tool types that we use for software development security. And where would we put these tool types? So I've listed here, this is the software development pipeline for DevOps. And this shows where we would place those different tools in DevOps. But we do have this idea called shift left security, and it's a DevSecOps idea, I guess is kind of how I position it. But the idea or the intention behind it is, what happens if we move our security tools closer to the developer? They get the results of the weaknesses and vulnerabilities sooner so that they can address them while they're doing the development of the application, and not after the application's been published in production. So it makes it easier and faster for the developers to solve security problems within their code and open source items that they might be trying to use or implementing in their code. In addition to the tools, we'd want to have a policy. And I'm really big on policies for security. So I've got here some recommendations on a policy, but as an organization, you'll want to customize it for your needs. For the policies recommendations that I would include in a software supply chain policy is make sure that we follow software development process best practices for security. So think about your OWASP top 10 as one of the types of secure development practices that we would include. You'll want to scan your source code and the compile code for weaknesses and vulnerabilities using those different tool types that I've presented a moment ago. Identify and disclose vulnerabilities internally and externally. If the vulnerability is exposed to your user base, make sure they're aware of it so that they can protect themselves. Create a product vulnerability response program. We have incident response programs, and in this case, it's for software teams. So you have a software architect. Do they have a response program in the event that malicious code might be embedded in the applications that the organization is using. Use proactive exploit mitigation technologies. So your software scanning, your source code scanning can also look for exploits that would be embedded in that source code that was provided or that's being developed by your team, your development team. Implement patch management capabilities. Use third-party assessments. They'll be unbiased in their responses, and that'll help you in making sure that you address all the weaknesses and vulnerabilities that would be identified. Participate in the Common Vulnerability and Exposure Program. You might run across a 0-day, which is just a malicious code or that has been that's never been seen before, and so presenting that will help other customers secure their organization and secure themselves from these types of attacks. Use an approved software supplier list and use an approved open source supply list. The different licenses that open source uses have different requirements. In some cases, if you enhance the capability of an open source library or dependency, and it's under like the GPL license, you're required to share that improvement or that enhancement. Whereas with the MIT license, you're not required to. It's a pretty general use license. So make sure you understand those different open source licenses and build an approval policy on which ones are allowed to be used within the organization. So what I tried to show today, software supply chain attacks are continuing to grow at an exponential rate. As a result, our leadership, our executive team is aware of them, and they want to help secure our software development programs. So we use the different tools and that I've implemented or mentioned earlier, the different tool types that will help us with discovery and remediation. And then develop a policy for software supply chain security in a way that helps you reduce the risk of an attack of malicious software that gets embedded into your organization. I left a lot of time here for Q&A. This is a relatively new item that's in the security space, so I wanted to give as many people an opportunity to ask questions as we could. But if you'd like to connect with me, I've got my LinkedIn here. You can scan that QR code. It'll take you straight to my LinkedIn page. Love to connect with you guys, and we can have an offline conversation, 30-minute diagnostic call if you'd like. But at this point here, I just will turn it back over and start doing Q&A.
Thanks, Keith. Why don't we do this? Pull up the chat. There's been some comments and questions in there.
Sure.
And that way, anybody who does have a question, can reach out to Keith now.
So the first question that came up, Log4j is a great example of an open source attack. Is there anything that Santa is going to leave us under the tree this Christmas? There's not from what I'm seeing, but there are these types of attacks. They're hidden, and typically they're like 0 days. You don't know until they show up, and then once they show up, then we start recognizing the pervasiveness of it based off of how much that application has been distributed. A lot of people got hit with Log4j. In fact, I know some of my customers that were impacted by Log4j as well, and it was a big scary moment. And what was really interesting is how quickly the application that our customers used, those different application companies responded very quickly and were very open and quick to admit that they have it, and here's a patch coming, here's how you can mitigate it. So it's really great that we can see that support in the community. How do we decide which solution would be ideal for a hybrid cloud enterprise? This is a really interesting topic for me these days, because what we're seeing is a lot of our security controls are still in the data center, in our corporate data center. but we've moved to a distributed business environment where our applications, our platforms, our infrastructures are in the cloud. Our users, our workforce is now distributed. They're not in the same location. So determining which solution you would be ideal for a hybrid cloud enterprise, I do believe that if you focus on tools and technologies that are cloud-based and go ahead and start looking at moving your security controls and capabilities into the cloud and out of your traditional data center. There's a lot of really good reasons to do that. And I could make a whole nother presentation on that. So how do we get the development team to own the responsibility of performing vulnerability scanning early in the development process? It depends on what your development process looks like. If you have automated development processes, if you're using like a Jenkins or Azure DevOps, where you've got automation built in to do the code compiling, build, and release and deploy, then you don't have to get the development team involved in the process of vulnerability scanning. You insert the tool into the pipeline, and then when the code goes through the pipeline, it will automatically be scanned and a report will be generated and sent back to the developer. Another way that I've seen used, and I have some experience with this as well, is we have the ability to put security scanning in between the QA testing group and the developers. So we do our QA scanning at the same time as the testing team, and it's all kind of in line. So whatever the results that come out of the tests from the testing team will also contribute to the results of the security analysis. So we think about, and I'll give you a great tool that I think I just love the tool. OWASP is a great organization, and their Z attack proxy will sit as a proxy between your QA team and the application. So as the QA team is running web-based scans through the proxy and then ultimately to the application, the proxy will find and identify vulnerabilities in that traffic and then present that as a report.
Well, thank you so much, Keith. This has been really great. Great participation and questions from the audience. Thanks again, Keith. Have a great day.